take a look at it. Okay. This talk is about building a web application, despite of its name. Each time I commence work on a web project, I feel a disgusting and frustrating unnecessity of intermediate layer. PHP, Python, Perl, whatever scripting language. And each time this feeling grows stronger. So I insist that database is enough for building a typical web application. People have forgot that a database itself is an application server. And moreover, it was intended to satisfy an end user. And many years of development were not spent in vain. The database developers had succeeded in the task. Particularly PostgreSQL is far beyond average expectation. It has the real power to compute, not to be a trivial trash can for tweets. And this talk assumes that we are using the following software: PostgreSQL as a database server, Nginx as a web server. It's extremely fast and lightweight web server, and PHP FPM as a parasite J between them. The question why is almost outside of the scope, yet I'm ready to provide you detailed answer later if you wish. The main idea is to delegate as much work as possible to a database. It allows me to reduce selects overhead. So I minimize the amount of data transferred out of a database. And I minimize the amount of selects addressed to a database. It allows me to use native user permission system, which is particularly good in PostgreSQL. Naturally, it minimizes execution time of relatively slow PHP script or other scripting languages. They are all relatively slow. And the most important one, it allows to avoid intermediate data representation. To operate with any data in any way, you inevitably should establish a representation of this data. So, your task inseparably consists of the two parts: to code algorithm itself and to code data representation for this algorithm. But data representation is already implemented inside the database. So we have an option to save half a programming labor simply by delegating data processing to the database. Keeping in mind that database is a special tool designed exactly for data processing. And delegating labor to database also allows us to define an efficient access control scheme. I have defined two database users, functioner and reader, where functioner is granted with all permission on all tables, and functioner is also definer of all functions. And the reader is granted with only select and execute permissions, where functions describes all possible data modifications, and each function is defined with the special attribute security definer, which means that this function acts on behalf of its definer rather than on behalf of its invoker. It's similar to set user ID bit. So if you call a function defined with this attribute, security definer, it obtains permissions of its definer, and it is able to update tables regardless of its invoker. So the reader is actually able to update data, but he is restricted with this predefined function set. The keyword is predefined. By this moment I feel that this speech, this scheme needs a sort of apology. This method looks too simple to be mentioned explicitly, but surprisingly it is not a mainstream method, and this is why I paid attention to it. Moreover, I respect the elders' intentions to make database end-user friendly, but humans had failed to speak SQL. They proved themselves stupid enough to not to be able to speak SQL to database. Therefore, human is an end user is not a user, is not a database user nowadays. A database user is a program nowadays. Nevertheless, it gives us an advantage. Advantage is we define the entire interface for access data. Therefore, we may implement our very own access rules, whatever complex access rules. This is an advantage. And in the living example of Platzkart comics, it looks like this. Reader user password is hard-coded in PHP script, and reader is granted to take actions on behalf of every end user. But functions, these stored procedures, requires exactly the end user credentials. And these credentials are not known to the script. So the reader, the system user, is not able to damage byte. Naturally, we keep our system users, readers and functioners, and our end users, humans, separately. But the both user permission subsystems, this one and this one, still implemented inside a database. On the other hand, we have functional user that is almost dangerous as root user, and he is able to perform almost any action, but no one knows his password. All connections came with reader credentials. You may even revoke connect permission from the user function. Apparently, this user access control scheme affects potential SQL injection threat. Imagine we have an SQL injection hole, and someone managed to inject the SQL, and this SQL will be executed. But it will be executed with reader permissions, and consequently, it will do nothing. So, all in all, SQL injection threat is a threat imposed by a system user. Simply do not overgrant a user, and you have nothing to be afraid of. That's from this point of view, the classical recipe to filter entire input seems slightly wrong. Input filtering looks like patching a leaking pipe. And moreover, it is too spread to be under your full control, which makes it incapable of being a good security measure. The input filtering itself is not bad. I'm practicing input filtering for many reasons, but you should never rely on input filtering as a security measure. All security measures is your system users. Since database is the best tool to arrange access control. I may reply. Database is the best tool to arrange access control. This is the big picture of Platzkart code. All in all, it still uses PHP, but barely. The PHP role is pretty simple and straightforward. It only defines appearance of web pages. In terms of model view controller, the whole set of PHP scripts is a set of views. And the entire business logic is implemented inside database in one piece with access control rules. From the point in terms of MVC, these are controllers. And data model is a data model, nothing more and nothing less. And it is a leitmotif of this talk. Well, back to PHP. This is the most primitive, simplest PHP example. No. Give me a second. One slide back. It is pretty unusual system design, but I'm still thinking about even further unusual system design. I plan to get rid of this PHP burden. It obviously simplifies the system. I want to explain why I consider PHP a burden. So, to PHP. This is the simplest example of typical PHP routine fetching a result from a database. This procedure is a transformation of a result object that we got from a database interface into something useful, and this something useful is always a text. And this snippet is all about this fetch call shown in red, and it shows us that we must always fetch, we must always call this function, because result object is not a result a programmer is working for. Programmer is working for a text. So in PHP, it is not difficult to fetch result, but it's surprisingly prolix. You have to repeat amounts of low-level calls and moving values from one temporary storage into another temporary storage, and so on. Ideally, we want to get a text, a pre-formatted text. This is the example of my dream. It's merely a single call. I wish to get the text formatted like this and fill these fields with the select result. That's all I need. And what is the difference? The difference is the abstraction level. In PHP, you have to care about low-level result representation. And while this procedure is obviously algorithmic, and this procedure is typical, each PHP programmer is forced to code these 3 lines of code time and again. And it's extremely typical. Each request for data to a database, you inevitably forced to code its transformation from a result object into the text you need to display. So I don't want to care about low-level result representation. And it is possible to achieve with PostgreSQL. This is the same routine implemented in PLPG-SQL. It is still a cycle, but there is no low-level result representation. I select the whole row of pre-formatted text at once. It's not that perfect as my dream, yet it is much better than PHP. It is much better for 2 reasons. The first, select is native part of the language. So we do not have to maintain this intermediate representation. And look at this picture. The only user of database is PHP in current layout. The behavior of PHP is determined by the finite set of arguments, and it returns merely a text, while PostgreSQL is perfectly able to run imperative routines. So why not to codify, to implement the same algorithm inside the database? It is possible, absolutely, but this connection, this link between web server and database looks like a problem, but it isn't. The solution is Nginx Postgres module written by Piotr Sikora. It allows us to connect Nginx directly to database like this, and it makes request processing at least 1/3 shorter. We got rid of parasite G of the PHP, and a shorter processing is always better than a longer one. I'm sure about it. While it is not hard to, it is very easy to ask my beloved Nginx to obtain data from database. It is not harder than to ask Nginx to obtain data from a FastCGI server or other sources. We simply define PostgreSQL connection. We define connection to a database, specify it, and in location section we must specify only 3 rows: which database to connect, which query to send, and how to treat a result. This option text means return the plain text. Simply dump all the fields acquired from a query, separated with line feed character. And apparently this text can be a valid HTML. Why not? So it is not a bit hard to ask Nginx to take a query result as a reply text to send back to a client. So we have the following layout after all, where almost everything is under control of database. We finally implement views inside the database, and this layout raises two frequently asked questions. What about model view controller, this classical recipe, and what about object-oriented programming? Now, answering the first one, let us compare classical MVC layout against my layout. First of all, and the most important, that the data model is solved unlike two duplicate data models in MVC. And this duplication is a burden for a programmer, obviously, and it is a burden for a computer in runtime. And this duplication abuses this link. In my layout, views rather integral with data, and you may consider it a disadvantage. However, in my opinion, it is a small advantage, and because it reflects natural dependency of views on a model. And the third, and more important than the second, controllers are more able to perform access control in this layout because they are implemented inside the database. If you implement access control scheme outside of the database, you again abuse this link, and you make the whole access control subsystem easy to bypass. There are many issues about bypassing such a control systems. And while you develop your very own access control system, you spent resources and you left ready to use tool completely unused. It is a sin to waste power. Some examples of MVC in real life. There is example of from say somewhat popular website. It selects all fields and then immediately drop them all, populate array with them, and then immediately drop them all except one. Almost the same stupid job performs the second example, but the second example is more object-oriented, since it is trying to hide its stupidity behind the method call. So here's the stupid job: select all, populate array, and drop them all, but it is slightly hidden. Plus some extra fun with question mark operator. Take a look at the second and the third argument and this comparison. The third example is the most object-oriented of all, since it is look really perfect, and at the same time it performs way more stupid job. Look, it loads some objects and then loop through them for each call a method of each object. What is wrong? The wrong things are hidden exactly as object-oriented programming demands. Behold. First method, load some object. First method, load some object. It selects several records from a table, and it is nothing wrong. Second method updates exactly one record of the same table, and there is still nothing wrong. But in combination, they produce imperative cycle, notice for each, of updates. So you select several records, and then for each particular record, you call update query as many times as many records you selected. So you produced a multitude of queries instead of a single primitive query. Have you seen the way, how did they manage to produce hundreds and sometimes thousands queries per web page? Have you seen why all the popular websites are so slow nowadays and being constantly refactoring and crying for scalability solutions? Do you see why rumors about, why do they always complain about SQL low efficiency? And why the rumors about a mysterious NoSQL so popular nowadays? The answer is database misuse. The database misuse influenced with MVC and OOP ideas. Well, generally needless work, as described in previous two examples, is an essence of object-oriented programming. There is another issue, and I call it representation collision. Database provides you the highest possible abstraction level. And when you try to re-represent your data in terms of object-oriented classes, you dramatically lower the abstraction level. And when these two representations collide, a programmer is trying to break the self-sufficient working thing into small pieces suitable for his ugly object-oriented instruments. And this kind of unnecessary labor looks like a diagnostic surgery on a healthy patient. No? Remember, database provides you the highest possible abstraction level. What about OOP aside of MVC? Besides the fact that OOP is pure evil and should be thrown away, besides the issue described above, there is simply no room for object-oriented programming in a typical website. Take a look at the example. Is it bright enough? And this code is intended to set a single cookie. It takes with object-oriented programming 4 lines. And without object-oriented programming, it is merely a single call. And take a look at the essential information shown in yellow. It's easy to see that without object-oriented programming, information is way more concentrated. It shows us that object-oriented programming is very good for code bloat. And I suspect the reason why the object-oriented programming is so popular. It is probably because of companies that pays per line of code. Look, it is not a worst practice example. It is mainstream example, since it is official example of YII framework. You consult their manuals and behold this example in vivo. Oh, what about the previous examples? Previous examples are also mainstream examples. This is not the worst practice example. The author of the man who wrote this field, this particular line, is now a chief software developer in a middle-sized Finnish software company. The man who wrote this field is now teaching other programmers to program. So this is the example of very respected mainstream. So there is no room for object-oriented programming on a website. But object-oriented is good for code bloat. No? Easy to see. I cannot characterize object-oriented programming as precise, as exact as one object-oriented supporter characterized it. He said, "I see no reason to complain, silly. Just write a wrapper function, just like any able programmer does. If you can't, you are just stupid." So this is the very essence of the object-oriented programming. Everyone writes wrappers, me included. Back to our system, the Latskat call. So we achieved the following layout, and as I said, everything is under control of database. Yet there is still the way to improve this layout, the views. The least sophisticated and the most independent module. Though you may need a template engine or such. There is no obstacle to elaborate one inside the database. You have a general purpose procedural language inside PostgreSQL, so feel free to improve views this way. But it is not my way. Fortunately, the Ajax has developed, rather to say, hiding of Ajax has ended at last. Better late than never, but I think that Ajax should be the default behavior of the very first browser and the only behavior of any browser. That is subject of another talk. So, I hate the fact that my server has to repeat so numerous times so dull routine as calculating web page appearance while thousands of client machines stay cool. I hate the fact that my clients have to wait for my server to calculate web page appearance while typical client machine is times more powerful than my server nowadays. And finally, I hate to flood the network with HTML pages. So sending HTML pages repeatedly is definitely a flood because they contain so few useful information, badly diluted with tons of meaningless decorations. So the solution is, my particular solution that I'm experimenting is Ajax. My website serves the entire HTML, the whole set of HTML templates to the client in the first request, and it hands over to a client entire JavaScript code of display functions, and then it replies to the subsequent calls in a lightning fast and brief manner by transferring data only. So we have one heavy request, the first request, and huge amount of very short requests, very short replies consequently. So by transferring data only, I save lots of traffic and lots of my clients' time. They aren't forced to wait. The illustrious example, the one function framework, is located at this URL. It is a wrapper. Yes, I am writing wrappers. It is a wrapper for Ajax objects. It contains only one function, one function accessible for an end user, and it simplifies Ajax usage to the limit. Don't hesitate to give it a try. So we have the following layout. We moved our views to the browser side, and we left only simplified views inside the database. And now Nginx plays its invisible role perfectly, parsing arguments and cookies, dispatching localizations, checking captchas, Nginx, transparently. And the database is finally used properly. It is used as it was intended from the very beginning of the database development. So the Nginx and PostgreSQL plays a do it. Now, it's a time to talk about yet another sacred cow. It's a new subtopic I added recently. Let's talk about multi-tier architecture. Not so long ago, I had a practical conversation with a younger programmer about the REST interfaces. I just consulted him. And he asked me, how do you take care of transactions? I felt confused. Do they need any care? Since they are intended to make my life easier and carefree. Why should I care about anything that a database is specifically designed to take care of? So he replied, what if you need to modify either a pair of resources or none of them? I answered, obviously, I use transaction in this case. For I prefer to represent each non-atomic action as a stored procedure inside the database. Therefore, transaction is implicit. Nay, he screamed. I mean, what if a client have to do so? I still felt confused. For example, client post command post resource 1, then post resource 2, and he have to post both of them or none of them. How do you prevent a client from performing one of these two post requests? And by this moment, I had discovered the precious idea I had practiced all the time. Look, I do not prevent a client from any sequence of commands. And I do not impose any restrictions. I simply design the interface the way that any command transits server from one consistent state into another consistent state, so that any sequence of commands is acceptable and valid. In other words, my intermediate layer talks to a client in terms of business logic, and it talks to database in terms of data entities. And then I have deduced the following generalized judgment. Each tire must speak different abstractions to the surrounding tires. By this judgment, you may judge if you need a tire at all. And if you are developing kind of transparent tire, let's say transparent REST server, you are about to create a very complicated network cable. That's about multi-tire architecture. And to achieve these, so one slide back. To achieve these, look, I thoroughly inspected user actions in the first time to discover what do they really need to perform. And then I'm trying to elaborate the equivalent set of stored procedures, keeping the relation between these two sets as close to the bijection as possible. That's the essence of the process. Though the process isn't that simple as it sounds, it's quite a creative process, but the essence is to keep relation between user action and stored procedures as close as possible to the bijection. So, that's all, I presume. Any questions? No.
Yeah. A very interesting and thought-provoking talk, I want to say. It's not strictly a lesson. The only slight thing that kept on popping into my mind while you were talking was basically a practical problem, so a lack of libraries.
What libraries do you need?
I was thinking, for example, if I want to implement OpenID authentication, right?
Oh, for OpenID authentication, you may do the following. Look at this one. You have an Nginx, and Nginx is more powerful than you can imagine. Also it is possible to link Nginx with a special module called Nginx subrequest auth module. That module is responsible for authentication by subrequest, and it is completely transparent to the client. So the client just requests some page, some information. Then Nginx makes its own request to authentication server, whatever you need, any server you want, and then it decides whether to give you access according to the reply it got from authentication server. So such mechanisms of authentication as OpenID or something, standalone mechanisms, do not affect this part of the picture at all. Mm-hmm. So, I have a few words to add that nowadays on the millions web servers all over the internet, they are running instances of application servers. They are actually duplicating database labor. If you follow the recipe of model view controller, you significantly duplicate database labor in your scripts. That's the point. So, if you have a time, we may pay attention to several subtopics. These subtopics were not included in the talk because they make it too lengthy. It's about software we have used in development of Platzkart.com, why we use particular software. About scalability solution, how we have decided to balance workload among several machines. All these subtopics are available in PDF version via HTTP. So if you are interested, you feel free to download and read. About HStore usage, so PostgreSQL contains several non-atomic types, such as arrays and HStore. HStore is a type that represents a set of key pair values. Key value pairs. A set of pairs key value. It's an extremely useful type, despite the fact that it looks like it disturbs the normal form. But I can describe how to use it to not disturb your normal form. Another subtopic is about storing the most precious secrets of your clients inside a database. And another one is about versioning. How to maintain your running instances of, if you have multiple instances of running instances of your database, how to maintain them updated, up to date, and how to avoid this double labor, since you have tried to maintain the running instance and you have tried to maintain initial init script, because of the limitations naturally imposed by DDL, you cannot apply initial database init script to a running already running database. So if you want to maintain both the running instance and the init script up to date and synchronized, you have to organize it using APG-Diff. So I bet APG-Diff is the best tool for this task. And the last subtopic is about PostgreSQL bugs. Most notorious. This subtopic contains a lot of fun, if you wish. It's very obvious and very fun bugs. What, for example, this one? Well, extract epoch from epoch is not 0 in PostgreSQL sometimes. If you wish to discuss this bug, feel free to do so. If not, then you're dismissed.
I just think you might want to add a mention to object relational mappers in your discussion of how useless is object-oriented programming and everything.
Okay.
And the fact that you are deduplicating stuff and you have two different representations, one in the database and one in the
Yeah.
You might want also to mention that this is why we have object relational macros.
I can get your point, honestly.
You can get. We have to add another layer of stuff in order to avoid the fact that we always need to translate from the database representation form to the form we use in our programming language, right?
You always need to.
Yeah, when you program in the way you don't like.
No, if you're programming outside of a database.
Yeah, exactly. If you're programming outside of the database, like a lot of people does, you need you might want to have object relational macros. So this is something that I think makes your point even more interesting.
They should not. They shouldn't do it. They should not to implement application layer outside of the database. Because of this issue, they have to implement data representation anyway. You may call it whatever you call it. It is a data representation, and it is the second data representation after the data representation in a database.
Mm-hmm.
So you may use object-oriented programming or not. Duplicate labor is obvious.
Mm-hmm.
So my critiques about object-oriented programming is not related to the duplication of data representation. It is related to abstraction level of the data representation in terms of object-oriented classes. It is much lower level than the level of abstraction that a database provides. So this is a two dependent but different points related to the object-oriented program. One is more general, and the second is more specific to object-oriented. Anyway, I haven't met a tool or a library or how to say convention about data representation in a memory of a imperative language that is as high level of abstraction as database. Database provides you no default ordering of records. Yes, you may order records in any way you wish. So if you want to achieve such an abstraction level in your application, then you are going to implement your own database system inside your application.
The vast majority of the application we see nowadays, though, use the DB just as a place where you store stuff.
Yes, just a trash can for tweets. They only put their records and occasionally select it, but they do not use its true power. It is seen to misuse tools. You have asked?
The database is the permanent data store, and that's all.
Not. It is not all. Database.
That's what I use it for.
Users usually treat database just like permanent data storage, but data storage is only a part of a database. Significant part, but as I said, database is an application server itself, and it was application server in intention of the elders. It was intended to be application server from the very beginning of database era. Thanks.
Okay.